It's always the analog things like projectors that cause problems for things like this. Well, thank you very much for coming. My name is Greg DeMichillie. I'm the Director of Product Management for the Cloud Platform at Google. That means I lead the team of product managers responsible for things like App Engine and Compute Engine, the developer experience, our developer tools, the billing system, basically anything that you touch as an end-user developer coming to the Google Cloud. Because the way we work at Google, I'm also responsible for the product management teams that build the fundamental infrastructure that Google itself runs on. So if you think about what we do, we allow you to build on the same infrastructure that we use ourselves at Google. And our team of product managers is responsible for both the internal and the external facing parts of that. I've got a background in developer tools. I was at Microsoft for 10 years in the 90s. And so I've been building things for developers my whole career, and I'm really happy to be here in Tel Aviv where there's such a vibrant community of startups and ISVs and IT. I've only been here so far one day, and this is my first trip to Israel, but it's really exciting to be here, so thank you for coming. I thought today I'd start with at a high level and then go down into giving you an overview of what the cloud platform actually has to offer. First of all, if you think about what's happening in the way we build applications today, there's a number of things that have fundamentally changed the way we build applications. The first is this almost limitless capacity that we have available, and not just available, but cheaply. A statistic I saw the other day said for about $600, you can buy enough disk storage to store all the world's music. That's phenomenal if you think about it. You think about a time not that long ago when to build an application, you had to buy hardware, you had to buy storage, you had to buy networking. Before your first customer even came to your website, you had thousands and thousands of dollars that you had to put up front. Now, with the way that the cloud is developing, you don't have to do that. You really have limitless capacity available on demand when you need it in a real-time way. And if you think about the way applications tend to work, they tend to fall into a couple patterns. The first kind of application pattern you see a lot is the classic batch computing. Every night at 2 a.m., my system runs a report from all of yesterday's sales, and at 4 a.m. it's done, and then it sits idle for the next 22 hours. And in that model, you buy a computer, and you pay for it 24 hours a day, even though it actually is only running a task for 2 hours overnight. And so you have wasted money. Another pattern you see is the hyper-growth company. You're at a startup and you're doubling every week the number of users you have. And now you're faced with the task of, can I even buy computers fast enough? Can I go online and order hardware and get it installed fast enough to keep up? And the answer is no, you can't. So you're immediately faced with the choice of buying too much to satisfy your growth, or having unsatisfied customers because you can't keep up with the growth of your company. We see the unpredictable bursting. My application is running fine, and I'm serving my customers' needs, and then I end up being on the front page of Reddit, or I get picked up by a blogger, and all of a sudden, out of the blue, my network traffic goes up 10, 20, 50 times. What do? As a business, I can't afford to provision enough capacity just in case I get massively popular, so I end up again having unsatisfied customers because I couldn't meet up with demand. And the fourth pattern you see a lot is predictable bursting. Think of FIFA. Very predictably, every 4 years, the World Cup happens, and there's a huge uptake in their traffic load that they have. And very predictably, once the World Cup's over, it settles back down. So what do? Do they buy enough capacity to handle that peak when they know it's coming, even though it's going to be wasted? Or do they again have this risk of potentially having unsatisfied customers because they couldn't meet the demand? All of these speak to the need to move away from the model of owning your own hardware, provisioning your own hardware, and onto a model where you can provision hardware on the fly, and your application can use as much compute resources as it needs, but only the resources that it needs. So how does that relate to Google? Well, it turns out Google has been facing this exact problem for 14 years. From the moment we built Google Search, we had the problems of how do you deal with going from thousands of users to millions or billions of users? How do you provision capacity so that you're not wasting it? How do you get power efficiency? And along the way, we've had to invent a number of hardware and software techniques just to make Google work. If you think about it, when we set out to build a search engine for the internet, the first thing you realize is you need to store multiple copies of the entire World Wide Web. How do you do that? There's no file system out there when we started that could hold 3, 4, 5 copies of the entire World Wide Web, so we had to invent that. There were no storage systems we could go buy off the shelf that would satisfy that, so we had to invent storage technologies. And time again, as we've built things like search and apps and Gmail, we've had to build out the fundamental hardware and software infrastructure. And what we're doing with the cloud platform is we're taking all of that infrastructure that we had to build for apps and search and Gmail and Maps and Android and Docs, and we're now opening it up so that your applications can run on that same infrastructure. These are some photos of some of the data centers that we have, and frankly, they're as pretty to look at as they are to run on. I think this one is in Finland. I'm not certain. And it's not just the infrastructure of servers and storage, it's also networking. One of the things you may not know is that last year, Google, in partnership with a couple other companies, we ran our own cable underneath the Pacific Ocean to connect the US to Asia Pacific. In fact, we're the only non-telco, non-telecommunications company that owns its own submarine cable under the ocean. And we do that because we needed high-capacity networking for our data centers in the US to our data centers in Asia Pacific. And this picture you here see in the middle, that you can't quite see it, is actually the cable being laid at the bottom of the Pacific Ocean, the trench being laid, the optic cable being run. Those are the kind of investments that we're doing in our infrastructure in order to keep pace with what we need, and we're sort of inviting you along for the ride. It doesn't stop there. Last year, we announced publicly that we're spending $2.9 billion US in additional infrastructure, data centers, more computers, more storage, networking capacity, power efficiency, and this is going to continue. And we really don't see a slowing down in this. But it's not just hardware. It's also about software. I alluded to this earlier when I talked about search and the fact that we had to invent our own file system. That has shown up time and time again. In 2004, we released a public paper on a technology called MapReduce. You now know that as the foundation of Hadoop, right? Internally, we've actually already moved off MapReduce, and we're on to the next generation, something we call Flume, and that's the technology we're using to do our own MapReduce-like workloads at Google. Similarly, we've made investments in software like Bigtable, which is a storage technology that allows you to do NoSQL-like data storage with incredibly high reliability. And again, we've published a paper on that, and that is the foundation of what you see in the cloud data store that we'll talk about. Dremel, a technology to allow you to do querying of non-relational data with a SQL-like language interface. Spanner, Colossus. These are all places where we've advanced the state of computer science. We've published papers, and we're building now our cloud platform products on top of those, so that as we continue to invest in the software to run our own business, we're exposing those to you as developers, and you'll see that as we go through the actual components of the cloud platform. And in fact, you know, it's just us. When we've invited other people to come look at our product, Wired, we gave Wired a tour of some of our data centers, and they really came away with, it's not just about software and hardware, it's the combination of software, hardware, and our efficiency that allows us to actually run and deploy that hardware and software. That's another favorite pictures of mine of one of our data centers. It's interesting, people ask the color of the pipes, did we just paint those because they're the Google colors? It turns out it's not true. There's a standard color coding in data centers of red, blue, yellow, and green, meaning things like hot air, cool air, hot water, cool water, and it turns out that the standard is pretty much the same as the Google colors, but everybody else just paints or puts a little stripe around the pipe, and so we thought, why not paint the whole pipe that color, just because we think it looks better, and if you're going to work in one of our data centers, why shouldn't you work in a nice environment too? So with that, as background, let me take you through an overview of the cloud platform itself that we offer to you as developers. First thing is, it is a platform aimed at application and IT developers. Google also has software as a service products like Gmail and Docs. I'm not going to talk about those today. They're fabulous products. We use them ourselves constantly. We're going to talk today about infrastructure and platform as a service in the form of Compute Engine, App Engine, and the associated products. So first, just make sure we're level set about the differences between those different components. Basically, when you look at the cloud platform, you can choose how much control you want to maintain and how much automation you want us to provide for you. Starting with infrastructure as a service, at that level, we will manage for you your networking, your storage, your servers, and your virtualization. You still have complete flexibility and control over what operating system you run, what middleware you run, what applications you deploy. If you go to platform as a service, you give up a little bit of that direct control in that we now manage your operating systems and middleware and runtime. But in exchange for that, you get much higher levels of productivity because we can provide auto scaling, auto load balancing. We can provide more of that for you automatically. Think about this as the equivalent of programming in a high-level language and programming in a low-level language. Some things you write in C because you have total control and it lets you do everything you want, but if you write things in C, you have to worry about more of that yourself. If you write in a language like Java, you don't think about memory management anymore. It's provided automatically, but you give up a little bit in terms of flexibility. So we support whatever place you want to be on this continuum, from you manage it yourself to we manage it automatically. So let's look at specifically what makes up the cloud platform. We think of it in three broad buckets. First is compute. This is the actual application logic of the system you're developing, the actual compute services. Of course, you can't have an application if you don't also have storage. And we have a range of storage products, from traditional SQL in a cloud-hosted environment to NoSQL to file system-like storage as well. And then finally, there's a set of application services that you want to use regardless of what technologies you're using, around things like querying of data, integrating with mobile backends, caching, queues, things like that. And we're going to walk through each of these in turn. But it's important to point out that this is a snapshot in time, and we're evolving very quickly. In fact, in the last 12 months, we've rolled out 163 new features or major improvements in the cloud platform. Everything from new instance types in our virtual machines, to new programming languages in App Engine, to new pricing, new charging, lower prices. So what I'm presenting to you is a snapshot in time, but we continue to roll out new features on a very rapid basis. And in fact, we actually see this accelerating, not just holding still, but getting faster. As we hire more people, as we invest more, we find that we're actually able to increase the velocity at which we roll out new features. So let's take a look inside each of the parts of the platform. We'll start with the compute side. Again, this is where it's sort of the bulk of your application logic sits, the actual core of what your application does. And we provide two different models here. One is infrastructure as a service in Compute Engine, where you specify virtual machines and you have complete control, and App Engine, which is a highly managed environment. So let's start with Compute Engine. The main value of Compute Engine is it's a familiar environment. If you're running a Debian operating system on your on-premise system or on a machine under your desk, you can very quickly spin up a virtual machine that runs that same operating system, install the same software, manage it with the same tools, run the same applications. But what you get with running it on Google is you get the Google network, for one. Google has a very, very high performance network. you also get very, very fast startup times. We have virtual machines that launch from the time you provision the machine till they're up and running in about the 10-second range. And frankly, we think that's a little slow. We believe we have room to lower that further. And if you think about that again, that changes how you think about application development. If you could spin up a new instance of part of your application in seconds, it changes the way you think about application development, particularly when you add in some of the other capabilities I'm going to talk about. In addition, of course, we have persistent disk that you can store up to 10 terabytes of persistent disk per virtual machine. There's a wide range of operating system and instance types, everything from a fraction of a core. If you're running, I think we announced a fifth of a core. So if you're running very light workloads that you only need to run to short periods of time, all the way up to 8 and 16 core machines with a lot of memory. One of the features we announced at I/O that I think is pretty exciting is really related to billing. And I know billing sounds boring. How could there be anything interesting about billing? But bear with me. If you think about the way most cloud providers work today, you fire up a virtual machine, it runs, and even if you run it for 20 minutes, you get billed for an hour. So if you run for 61 minutes, you bill for 2 hours. What we've introduced is we actually now have per minute billing, so you actually only pay for the specific number of minutes that your virtual machine is running. If you take that, combined with the fact that you can start a machine up in a few tens of seconds or 10 seconds, you literally can start to throw cores at a problem because you can economically afford to spin up 1,000 cores for 10 minutes or 20 minutes. In most cloud providers, if you spin up 1,000 cores, you're going to spend a full hour minimum cost. So think about the way you develop applications and think about places where you could use a lot of compute capacity for a very short period of time. We're actually now allowing you to do that economically. I talked about the persistent disks. You can have up to 10 terabytes of persistent disk that's attached to your VMs. We also allow you to have multiple VMs attached to the same persistent disk, which again is a very convenient way for you to share information between instances. We have over 64 different instance types with operating system support ranging from CentOS and Debian. We have things ranging from fraction of a core up to 1, 2, 4, 8 core machines. You can choose whether you want a local disk attached to your device or you don't want a local disk. You can save money if you don't actually require a local disk running on your virtual machine. And we're rolling out all the additional features that you'd expect, things like load balancing we now have in preview, so that you can attach a cloud-hosted load balancer in front of your systems. And over the next year, you'll see us roll out more capabilities here. You'll see us add more operating system support to our platform. You'll see us add not just level 3 but level 7 load balancing, auto scaling, all sorts of capabilities are either will either soon be in a trusted tester or we've already demoed them at I/O. So that's sort of the do-it-yourself model of just give me a virtual machine. It's familiar. It's what I know. It's a low barrier to entry. But if you do that, you're still managing things like how you do auto scaling. You're still configuring your operating systems. You're still patching your operating systems. If you have a software problem, it's your engineers who are debugging your software problem. App Engine is a platform as a service. With App Engine, it's a fully managed platform. We wear the pagers, so if there's something that goes wrong in the system, it's Peter and his engineers who get the 2 a.m. phone call, not you. It is a very easy development model. You just upload your code, and then we actually deploy it out to the application. And it really allows you to focus on the parts that make your application unique. If you think about it as a developer, the mega trend over the last 20 years for developers is you want to spend more time writing code that makes your app different, not boilerplate code that's the same in every single application. And so App Engine is the next step in that process. App Engine automatically scales both the front ends and the back ends of your application. And in fact, if you are having no traffic, we scale you down to 0 and you pay nothing. And again, that's the sort of thing you can get with a fully managed platform like App Engine. In terms of features, we support the popular programming languages. For quite a while, we've supported Java and Python and Go. We've just now rolled out, and we announced at I/O, support for PHP. So if you're a PHP developer, you can now bring your PHP code and run it on App Engine. We provide a variety of storage options, and I'll talk more about storage a little later, but both SQL and NoSQL storage you can access. There's a variety of services. If you want Memcache to make your application faster with App Engine, you don't have to go and configure a Memcache. You go in the console, you check a box that's saying, I want Memcache. How much storage do I want? If you want, you can get shared Memcache so that your memory cache is shared among applications. If you want to pay a little bit more, you can have a dedicated Memcache that's for the exclusive use of your application, and you can specify exactly how much cache you want. We provision it, we manage it for you all automatically. Also, all the typical things you would expect. There are local development tools so that you can run your code locally on your laptop to test out your application, make sure it works. With one command line, upload the code, and you're up and running. Peter's going to talk a lot more about App Engine, I think specifically around PHP and some of these things in a little bit, so I'm not going to spend too much time on App Engine specifically. So that's the compute side. Now you've got your application logic written and hosted. What about storage? Well, storage comes in a couple different forms. The first is cloud storage. Cloud storage is your hard drive in the sky. You just have buckets you write to. You just give us a blob of data. We store it, and you can retrieve it. Think about it logically as sort of the equivalent of Google Drive, in that your application has its own, your project has its own storage place. You write things into folders. You retrieve them. We also have two types of application data storage. There's Cloud SQL, which is a cloud-hosted version of MySQL. So all the things you're familiar with MySQL apply to Cloud SQL. And we also have Cloud Datastore, which is a NoSQL key-value pair system. And I'll talk specifically about what that means. And finally, we have persistent disks, which I alluded to, which are those virtual hard disks that can be attached to virtual machines inside of Compute Engine. So let's talk about these one at a time. NoSQL, key-value pairs, SQL storage, so traditional schema environment, blob store in terms of cloud storage, and then block store. So let's take them one by one. Cloud storage. This is the analogous to Google Drive. It is high performance. You have very large storage capacity. If you are familiar with Amazon S3, we actually have an S3 compatible interface. So if you're currently using Amazon, it's actually very easy for you to start using cloud storage either as a redundant version, or if you want to migrate away from S3 onto cloud storage, we make that very simple to do. The key value here is that we provide Google networking, Google network performance, extremely high durability, low cost, and an SLA associated with it. Datastore is a particularly interesting one. This is the key value NoSQL storage. And again, if you think back to when I talked about building what we needed to build for Google, that one of the first things we realized, again, when we were building search, was there was no existing NoSQL store that was close to providing the reliability and the performance that we needed for search. So we had to build our own, and that what we built is in fact the underpinnings of Datastore. Accessible anywhere. This is the same. What we've done is we've taken this high replication data store that used to be just part of App Engine, and we've made it available to any application anywhere. So Cloud Data Store can be accessed from Compute Engine, from App Engine, actually even from Amazon. If you have applications hosted there, you can access the Cloud Data Store. One of the really interesting qualities it has is when you query the data store, the speed doesn't depend on the size of the data set. If you have a 1 megabyte data set, a query will take the same amount of time for a 1 terabyte data set as a 1 megabyte data set. So if you think about that, that also changes the way you think about application. We automatically replicate your data across multiple data centers, as many as 5. which means you have very high reliability, even in the event of natural disasters or power outages. We are able to deliver reliability that's far beyond what you would get from, certainly from any on-premise system, but even from most cloud providers. The statistic I find shocking or pleasantly surprising, Datastore is currently serving over 4.5 trillion requests per month. So not billion even, trillion. So this is a very reliable, very high uptime service. And it's the core of our NoSQL offerings. It automatically scales, again, so you don't have to provision it. It's a schemaless system. So if you are adding data, you just simply add new data. You don't ever have to do a schema-like update. It's available through both a RESTful interface and directly from App Engine. And again, it has built-in redundancy so that you automatically get replication in order to work from a variety of languages and data centers. Cloud SQL is a cloud-hosted version of MySQL, put simply. So if you're familiar with MySQL, this is a version of MySQL except where we do all the management and configuration for you. It is available in both European and US data centers, depending on your preference. It has very easy migration and data portability because, again, it is a version of MySQL. It's just one where we're doing all the management for you. And so between Cloud SQL and Datastore, you really have a choice depending on what your application is using. There's really no one-size-fits-all. Sometimes I get asked, well, should I use Cloud SQL or should I like Datastore? It really depends on what you're doing. Datastore is, like I said, a NoSQL, and it's designed around very large-scale applications. Cloud SQL is a more traditional environment designed to leverage all the existing tools and infrastructure that you're familiar with. So depending on both your application type and your data, one may be better or worse or a better choice than the other. So let me go and talk about app services a little bit, which is the third major category. BigQuery is a set of technologies. It's a fully managed big data analytics service. What that means is BigQuery allows you to upload your data in whatever form you have and allows you to do SQL-like analytical queries on it without having to configure data cubes or ETL or any of the things that make querying big data so difficult. And again, if you think about where this comes from, one of the problems that we faced early on at Google was analyzing log files, right? Why did the Maps application behave strangely for this user or in this region? Well, to do that, we actually needed to be able to look across the application logs for Maps across all these different servers and users and geographies. And again, what were we going to do? Build a data cube and take all of the logs from globally from the Maps application? I don't think so. So we developed a technology that's the basis of BigQuery that allows us to do queries in a SQL-like language against all these different data stores. And so that means that you can, again, query terabytes of data using a SQL-like interface. A great use for this case is just what we use for application logging. You can upload the log files of your application, and then your business analysts can quickly do queries to find out which users are using which features, or which users are experiencing what kind of errors. Basically, any sort of data that you have stored in your log files. Cloud Endpoints is a service that's designed for mobile apps. How many of you are building mobile applications? Yes, and the rest of you that aren't, you probably will at some point. One of the challenges you face as a mobile developer is connecting up your mobile application to your back-end data logic. Because mobile applications, even games, don't consist of just client-side code. They're client-side code plus server-side code that does things like high-score processing or rankings or selecting a player for you to play against. Cloud Endpoints is a technology that allows you to very easily connect up your back-end code to your clients. You can go into App Engine, you can pick a component of App Engine. With one click, you can create a cloud endpoint. And what that does is it creates a REST interface, and it creates the client-side library for iOS and Android that allows you to just make a call on the client and invoke code on the server. You don't have to worry about data marshaling. You don't have to worry about OAuth or any of that sort of hassles associated with connecting up a client-side, your client-side code to your server-side code. And so Cloud Endpoints is really designed on allowing you to focus on the part of the application that you care about and not about blue code. So who's using this? I mean, one of the things we hear a lot is, gee, that sounds interesting, but I don't want to be the first one to do anything, right? I want to know that there's somebody else out there who's actually being successful with it. Let me give you a couple examples of some customers who are actually using this technology. First of all, we currently have about 3 million active applications on a monthly basis running on top of the Google Cloud Platform. So it represents everything from small applications up to very large applications that companies are betting their whole business on. First one is Snapchat. I don't know if you guys are aware of Snapchat. It's an incredibly popular photo sharing application for iOS. It allows you to take a picture, send it to somebody, and then they can see the picture, and then after some period of time, the picture expires and is deleted. They're currently delivering about 150 million photos a day, all running through the Google Cloud Platform, both on the storage side and the compute side. Songpop is a game that allows it plays a song, and then you have to compete to who can identify what the song is the fastest. They currently serve about 18 terabytes of media a day coming out of the cloud platform, and they have about 80 million users on a daily basis accessing Songpop. How many have heard of Eurovision? Everybody, right? Eurovision this year, they were faced with the problem of their online voting system. They knew that they were going to have a big traffic spike. They knew it was going to come in a short period of time, and they knew that when it was done, they didn't need the capacity. So Eurovision came to us and said, would you help us build out this infrastructure? So they used Compute Engine, and at its peak, they were serving 50,000 requests per second as people were logging on to vote. 90% of those requests were served in less than 24 milliseconds response time. And so that was all built on Compute Engine. They were able to scale up, meet the needs. Now that it's scaled down, their bill has gone back down to nearly zero. Scalar is a US company that does cloud management, and in fact, they've done a number of benchmarks of VM startup time, VM performance, network performance, disk performance. If you're interested in a really good benchmarking of how we compare with other VM cloud-based environments, they're a great place to look. They're the ones who've really done a lot of really good work to sort of put our performance in context with other cloud platforms, so I definitely recommend you take a look at them. Udacity is an online educational software, and what I like about them is I loved the quote that I have here from their software engineer, which is gets at the point I've been talking about. I'd rather be democratizing education than scaling Memcached. And I think that's the essence of what we're trying to do here with the cloud platform. You've got some great idea for an application you want to build. We want to let you spend your waking hours building that application, not mucking about with a bunch of, frankly, boring infrastructure that somebody else can provide for you. Pulse is an online news reading application that allows you to read RSS and other news feeds. Talk about that hyper growth model we talked about. In 18 months, their user base went up 70 times. Without the cloud platform, there's just simply no way they'd have been able to maintain that. Their users would have had a bad experience, and frankly, their business would have just crashed and burned. Lastly, I want to talk about just raw performance with MapR. There's a benchmark out there called Minute Sort, and what Minute Sort does is it basically says how many random numbers can you sort in 1 minute. The world record for that was just broken on top of Compute Engine, and what I find fascinating about it is not just that it was able to sort 1.5 terabyte of random numbers in 60 seconds using 8,000 cores, but that the previous benchmark was done on custom hardware, and I believe cost on the order of about $1 million, the hardware. This version was done on a publicly available cloud platform with Compute Engine for, I'll have to look up the number. I believe it's on the order of a couple $1,000s. So it's a radical difference in the price performance. And it really sort of demonstrates one of the core values we've placed on Compute Engine, which is very high performance and very high consistency of performance. So with that, I want to transition over to Peter, who's going to talk in detail about App Engine. If I leave you with one thing about the cloud platform, it's that we are investing in fundamental infrastructure at Google because we need to, because we're building out things like search and maps. And with the cloud platform, we're really opening up that same infrastructure that we are using ourselves for you to run your applications on. This is the beginning of a process. You can expect over the next year we're going to have more features, more performance as we continue to invest more and more of this. And I'd love to talk to you during the Q&A or during the break to find out more about what you're doing and how our cloud platform could be the basis for your next great application. So with that, I think Peter is next to give you sort of a drill down on App Engine.